Hey guys, it's Mr. Canada. Today we'll be going over the first section of our new chapter that's dealing with sequences. This entire chapter will be containing 4 sections, and today we're just going to learn the basics and the fundamentals about what sequences are and the types of sequences that we're going to see in this chapter. So let's go ahead and get started. So here's what we're going to be covering today. We're going to be covering what sequences are and the 2 types of common sequences. We're going to be learning how to identify arithmetic sequences using their common difference, and we will learn how to identify geometric sequences using the common ratio. So let's go ahead and officially look into what in the world are sequences. So sequences are just lists of numbers that have some kind of order. Either it's a list that is from least to greatest, or it's a list that goes from greatest to least. So here are some examples. An example of a sequence that's from least to greatest would be like 2, 4, 6, 8, 10, and it just goes on forever. Notice how we start and notice how we end. We start with a 2, which is the smallest number in our list, and we end up to 10, which is the biggest number in our list. Now, I could keep going with my list, but I don't necessarily have to. That's what these 3 little dots mean. It basically says that my list is going on forever, but I don't have to actually write it all down. Now, what's an example of a sequence that's from greatest to least? Well, let's look at it from the other way around. Let's say, for example, your biggest number is, let's say, 20, and you're just going down by 5s each time. 15, 10, 5, dot, dot, dot. So both of these are going to end up being examples of sequences. They just have some kind of order, okay? So it's not too complicated of a definition. Just be aware that that's what it means. It's just a list of numbers, okay? Now, there are different parts of a sequence that you do have to be aware of. So every single number in a sequence has a very specific spot. That spot in the list or in that sequence is what we call a term. Now, there are a couple of terms that we are going to be focused on, but the most important spot, the most important term out of the whole list is always going to be the first number in our list. So, for example, look at the list we have right now on the screen. It's 2, 4, 6, 8, and then I put the 3 dots. It's going to go on forever. The number 2 here is the first number in your list. So we say that the number 2 is the first term. Like I said, term just means that it's that spot on the list. So you can have more than one term. You can have a lot of terms. But if you're trying to be very specific about what kind of term you want, you're going to have to say, hey, I want the second term. Hey, I want the 5th term. Hey, I want the 10th term. So you can be very specific about what number you actually want. So what's another example? Let's say the number 8. What term number would the number 8 be? All you would have to do is just count the number of spots that it takes up, or the spot that it's in. In this case, the number 8 in my list is the 4th term of my sequence. So we would say that number 8 here is the 4th term. It's the 4th number in my list. Now, in algebra or in math in general, it's important to know where the first term is or where any of the terms are, but it's also equally as important to know how you'll normally see these types of vocabulary words. One of the ways you might see it, besides the way right now it's presented on the screen, is using sequence notation. And sequence notation basically incorporates this kind of this type of symbol. It uses little a, and then at the bottom of that letter, you're going to write down what term number it is. So like we were saying before, since the number 2 is the first number in your list, we would say that the number 2 is a sub 1. When I say sub, I'm saying that 1 is at the bottom corner of that a. Likewise, if you wanted to represent the 4th term in sequence notation, you would say that this is little a with a little 4 at the bottom. So this is what we're going to be using a lot later on in this chapter. So it's important to know what the heck we're going to be talking about when we're using this type of notation, okay? So A1 just means the first term, If you wanted to represent any other number in your list, you would just say, hey, a little number this, depending on where you are on your list. So for example, think about this. The number 6 on your list. It's the third number in my list, right? So you would say that this would be a sub 3. Oops, that's an ugly 3. Sub 3. That number 4, it's the second number in my list. So you would say that that number 4 is a sub 2. It's the second number, okay? So just keep that in mind whenever you're seeing these types of symbols. So let's get into the two types of sequences that we'll see in this chapter. And most of the sequences that you'll see in high school. So there are arithmetic sequences that deal with only addition and subtraction. And there are geometric sequences that mainly deal with multiplication. So let's go ahead and break these down and get a good understanding about how they both work, okay? Let's start with arithmetic sequences. So arithmetic sequences have what we call a common difference. A common difference basically means that your list is always adding by the same number, or it's always subtracting by the same number. So one of the key things whenever you're dealing with arithmetic sequences is like the first thing you always want to look out for is, what is the common difference? What am I adding each time to continue my list? What am I subtracting each time to continue my list? Now, notice what the wording here, the word always. If you have a list of numbers where it's going up, but then it's suddenly going down, that can't be an arithmetic sequence. It's either always going up or it's always going down, okay? So how do we start looking for things like that? Well, let's say that you had a list of numbers like with the ones we had before, 2, 4, 6, 8. One of the first things that I always recommend is try to look out for the common difference. What am I jumping by each time to get to the next number in my list? Well, let's look at the first one, for example. It's 2, 4, 6, 8. You always want to start with the first number, in this case 2. What do I have to do with 2 in order to suddenly jump into 4? Now remember, if it's arithmetic, you're always going to think either addition or subtraction. Now how do you know which one you want? Well, notice that my numbers are getting bigger. Since my numbers are getting bigger, I probably want addition. So think about this. Think about what number you can add to 2 to jump to 4. And if you already knew the answer, then you probably guessed it. You're adding by 2 to make that jump. Now, this jump of 2 could be the common difference. The only way to make sure if it is to check, am I jumping by the same amount to the next number? So what I mean by that is it true that is also a jump from 2 from 4 to 6? And that's true, isn't it? I have to add 2 to 4 to actually get 6. So notice what's happening. I'm adding by 2 every time I want to get to another number in my list. Because I'm adding by the same number, I could say that this is arithmetic. But more importantly, here's another thing that you can also tell yourself. You could also tell yourself that the common difference, I'm just going to say common diff, is going to be positive 2. Because you're always adding by 2 each time. Make sense? Look at that second list. Notice that my list is going down. 10, 7, 4, 1. So instead of adding, we're probably going to be subtracting here. Now what we want to make sure is, are we subtracting by the same number each time? Well, let's check. From 10 to 7, I'm subtracting 3. Now, that could be the common difference. But let's check the next two numbers to see if it's true or not. From 7 to 4, am I also subtracting by 3? And we are. There's no other way we can get down to 4, so subtract by 3. Again, notice how we're always subtracting, and we're always subtracting by the same number. So basically, because of those two situations, we can say that this is arithmetic, and we can also say that the common diff common difference is going to be minus 3, because we are always subtracting by 3 each time. So that's the key idea with arithmetic sequences. You're either going to be always adding by the same number, or you're always going to be subtracting by the same number. And it's important to always look for that common difference first. It's probably going to make your life be a little bit easier. Let's talk about geometric sequences. Geometric sequences have what we call a common ratio. It's very similar to the common difference, but basically the only thing that's different about it is that the common ratio basically means you're always multiplying by the same number. Now, with geometric sequences, you might occasionally get fractions or decimals as your common ratio, and that's totally okay. One of the problems that I always see every time that this is covered is having the trouble of actually finding a common ratio. Because the whole idea is that you're trying to figure out, what do I multiply to get from step A to step B, from step B to step C? That's always the tough part. But let's keep it super simple, and I'll show you a way how to tackle that issue. Let's look at an example like this. So first things first, just like arithmetic sequences, we want to think about finding the common ratio first. And that's the tough part. Because sometimes depending on how big or how small the numbers are, it's kind of hard to guess, well, what exactly am I multiplying by? Where do I even start? And that's a good question to have. Now, here's basically the easiest way you can do this. The easiest way you can do this is take the first two numbers of your list, like for example here, 12 and 4, and divide them, and see what kind of number you get. So let's go ahead and do that. 12 divided by, let me go ahead and just bring that down here, 12 divided by 4, that gets me 3. So this is what you're going to check twice. When we divided 12 and 4, the calculator said that we are multiplying by 3. And that makes sense, right? 4 times 3 gets you 12. Now, how do we know whether the next two numbers have the same ratio? Well, let's check. Again, keep this super simple. All you're going to do is take the next two numbers, which in this case is 36 and 12, and you're going to divide them. We'll see what we're going to get. 12, oops, no we're not. 36 divided by 12 gets you 3. Hey, what do you know? So, when we divided 12 and 36, we also got times 3. So notice what's happening. We're always multiplying, but the important part here is we're always multiplying by the same number. In this case, we're multiplying by 3 each time. So because of that, we can say that this is geometric. We could also say that the common ratio is going to be equal to 3 times 3. Let's look at the second one. Let's keep the same principles, the same ideas, and apply them with what we on this sequence. Okay. If they tell you that this list is geometric, first things first, let's find out the common ratio. Again, if you're not sure how you're going to get from the starting number to the next number, the easiest way to do this is to just take both these numbers and divide them. It's always going to be second number divided by first number. And you would know if you did a mistake, because think about this. If you did 80 divided by 20, you get 4. So is it true that 80 times 4 gets you 20? Of course not, because think about that. If it was 80 times 4, we would get 320, but we don't have that. We have regular 20. So the order in which you divide is very, very important. So this is not the right way of dividing. So when you divide, it's always the second number divided by the first number. So 20 divided by 80 gets me a decimal, which makes sense because my number is getting smaller each time I go down my list. So this right here, we're multiplying by 0.25. Now you have to make sure that the next two numbers, when you divide them, gets you the exact same ratio. If it does, great, it's geometric. If it doesn't, we can think of a different answer. So let's check. 20 and 5. Remember, the order matters. So 5 divided by 20, it gets you 0.25. So that means here, this is also 0.25. The numbers match at the very end, which basically means that this is going to end up being geometric. And it also means that my ratio is going to be 0.25 because that's what we're multiplying by each time. In other words, every single time that I take the number on my list and I multiply it by 0.25, my number is going to end up getting smaller. So let's recap this. If they tell you that something is arithmetic, you need to only focus on addition and subtraction. If they tell you that something is geometric, you're going to be focusing on multiplication. Now, if you are having trouble finding the number you're multiplying by for a geometric sequence, the easiest way to figure that out is to take the first two numbers, divide them. Take the next two numbers, also divide them. If the result that you get from both is the same, then it's geometric. That also means that that result will be your common ratio, exactly how we have it right now in this slide. So let's actually apply this. Identify each sequence as either arithmetic, geometric, or neither. So here's my advice. My advice is to first check and see if it's arithmetic. If it is, you can probably usually just stop right there. You don't have to check the other two. Now, what if arithmetic fails? Well, then check to see if it's geometric. And if that's good to go, then it's geometric. If it's not geometric, then we can say that the sequence is neither. It doesn't behave either geometrically or arithmetically. But let's actually see it in action, okay? Look at this first number in the list. How do we know whether this this list of numbers, is arithmetic or geometric? Let's check. If you're going to check to see if it's arithmetic, you need to think addition or subtraction. Look at your numbers. Your numbers are slowly getting bigger, which probably means you should be focusing on addition. So ask yourself this. Am I always going to be adding the same number down my list? Well, let's first figure out what you're adding by the first time. From 10 to 15, it looks like you're adding by 5. So now you need to ask yourself, am I always adding by 5 to get to the next number on my list? It looks like I am, because 15 plus 5 is 20, 20 plus 5 is 25. Notice that the numbers are always the same. I'm always adding by 5. Because of that, I could say that this sequence is arithmetic, and I could stop right there. It's that simple. Look at the next list. 20, 10, 5, 2.5. Let's check to see if it's arithmetic first, and then we'll check to see if it's geometric. Remember, only check if it's geometric if your arithmetic test fails. Okay, so it looks like my numbers are going down, so that probably means subtraction. So I'm going to check to see if I'm subtracting by the same number each time. Well, from 20 to 10, I'm subtracting 10. Okay. From 10 to 5, I'm subtracting by 5. That's not a good thing. Even though we're subtracting each time, I'm not subtracting by the same number. So that's how I know it's not going to be arithmetic. It's not going to be this, because you're not subtracting by the same number. So let's consider the next option. Is it going to be geometric? How do I know? Take the first number and the second number, and remember, divide them and see what you get. So 10 divided by 20, remember the order is important. It's always 10 divided by 20, 0.5. So that means that I'm multiplying here by 0.5. Okay, now check to see if the next two numbers get you the exact same result of 0.5. So we're going to take 5 and 10. We're going to divide that. So 5 divided by 10 is also 0.5. So this is going to be 0.5. Notice that my number is always the same. That means that this number here, or this sequence right here more specifically, sorry, will be geometric. So keep that in mind whenever you're working through the practice problems. If they ask you if it's arithmetic, check to see if you're always adding and subtracting by the same number. If you're going to check to see if something's geometric, divide the numbers to see if there's a consistent number that you're always multiplying by. Now, I didn't cover an example where it's going to be neither. So let's go ahead and see what that looks like real quick before we end this video. Let's say you had an example where it was 1, 4, 9, 16. Okay, let's check to see if this is arithmetic. So from here to here is plus 3, but from here to here, it's plus 5. Even though you're not adding by the same number. So this is already not arithmetic. So this is already not it, because you're not adding by the same number. Okay, well, am I multiplying by the same number? Well, let's find out. Let's go ahead and take the first two numbers and divide them. So 4 divided by 1 is 4. Okay, so let's see. This is going to be a multiplication of 4. Now let's check to see if the next two numbers get us the exact same result. So 9 divided by 4. 9 divided by 4 gets me 2.25. So when we divided this next set, now we're seeing that it's not the same number. So we can now say that it's not geometric. So then what is it then? Well, it's just a sequence that we haven't talked about yet. And we probably won't talk about in this class. We would just say, for the purpose of this problem, that we would say that it's going to be neither. It's neither arithmetic nor geometric. Please do not hesitate to ask me for questions, either on Google Classroom or shoot me an email. Besides that, y'all please take care, do your best, and I'll see you guys next time.